welcome back to S-TechMatrix channel. So today in this cryptography playlist we will be looking into the classical encryption techniques. So in the last few sessions we spoke about why cryptography we need and symmetric and asymmetric cryptography. So we have went into it. So today we will be looking into the classical encryption techniques. So we will be more focusing on Vigenere Cipher in the classical encryption technique. So it's simple, even a beginner could crack it in a minute. But today we are leveling up, we are diving into the Vigenere Cipher. For 300 years this was known as unindexed-cipherable cipher. So today we are going to show you the math, the logic and exactly why the algorithm changed the history of cryptography. Let's get started. Okay. So two basic building blocks of all encryption techniques. So here that is substitution and transposition. To understand Vigenere, you first need to understand the two pillars of classical encryption, substitution and transposition. So substitution, this is where we swap one letter for another, and transposition, this is where we keep the letters the same but scramble their position alone. So we will be looking more deeply about the substitution and transposition from the future videos. So today we will be you just need to know that it is a one in which letter of plain text are replaced by other letters or by number or symbols. So Vigenere Cipher, now it's a mono alphabetic substitution. One letter always maps to other letter, but Vigenere is a polyalphabetic. Cipher is a monoalphabetic and Vigenere Cipher is a polyalphabetic. So Cipher we will be seeing in future further videos. So polyalphabetic substitution cipher, this means one single letter in your message could be represented by a 5 different letters in a cipher text. This makes it more harder for the hacker to find the pattern. So the process and workflow, we will be seeing it now. So here we will be looking the methods. There are basically two different methods to perform Vigenere Cipher. So I will brief you the each and every method. So method 1, in this method encryption and decryption are carried out using a Vigenere table 26 into 26 matrix. So for an example, if you can take the plain text as attack and our keyword is a key. Plain text is nothing but attack. Key, how we need to represent is K, E, Y, and then we can repeat that to how many plain text we have. So align the key, since key is shorter than attack, we can repeat it, there is no issue in it. So step 2, if you see, use Vigenere square, point to 26 tables from the slide, starting with K and column starting with A. Where they meet is the first ciphertext. So here A, K, A, here we have A and here we have K. So the ciphertext will be K and the next will be T. Here we have for that E now in this line. So X, and then again T, Y. Here we have so our K X R, and then A K again, so the K will be the, and C E H, then K Y, K I. So the ciphertext, if you see for attack, is K X, then R, then again if you see Y, C E, this is G is the ciphertext, and K Y I, K X R Y G I. So the ciphertext is KXYGI. So this is the ciphertext. And for D, so now using Vigenère Cipher table, you look the row starting at K and the column starting at A. So you got K. So for that, like that, you can repeat till the plain text converts into a ciphertext. So conversion, you can repeat this for every letter. This is a manual way, but now as an engineer we perform the math. Let's look at the formula. This is ciphertext. So now the formula method will be, here is the art of the algorithm. We convert letters to numbers way. The encryption formula, we add a numerical value to the plain text and the key, then take the module 26. So the decryption formula, we subtract the key from the ciphertext, we add 26 to ensure the result is positive before the mod operation. So the formula is EA is equal to TA plus KA mod 26. So the number we need to do is A to Z will be 0 to 25. So same, we can take this attack itself as a plain text and the key is a ciphertext. So I have the method 2 here. So this is the formula for encryption and this is the formula for decryption. Key. Okay. So now the A's value will be 0 and T's value will be 19, 0, C will be 2 and K will be 10. Like this we need to take it, and for key also we need to. If you see 10, these values 4, these values 22. So the cipher text is 10, 19 plus 4. So like this we need to add both the plain text value and the keys value to get the ciphertext of the plain text which we are working on it. So the next, like this we need to repeat for every step, and here we will be getting 43. We need to take mod for this, mod 26. So the value is 17 and again 10, then here CK 2, 4, 5, 6. Then here also again we need to take, we will be getting 34. So 34 mod 26, we will be getting 8. So the ciphertext value is 10, 23, 17, 10, 6, 8. On number. So now based on the number we can get the values for this. So the 10 will be K, 23 will be X, 17 will be R, then again K, 6, G, 8, I. So this is the ciphertext for the key plain text attack. So this will be the encryption for this. So instead of doing a plus here, you will be subtracting to get the normal value, plain text value for decryption. So now decryption they will be saying 10, 23, 17, 10, 6, 8. So now you need to minus the key value 10, 4, 24, 4, 24. So you will be getting 0, 0. Here you will be getting 2. Here you will be getting 19. And here for 17 minus 24. So you will be getting minus 7 and 6. 16 minus 16, so you need to take a mod value for this. So the value is 10. So 19 0 19 19 0 to 10. It's nothing but 0 19 19 0 to 10, the plain text. So this is how a Vigenere cipher works. So you need to here if you are going through formula method, then you need to convert the plain text letter into a number and key also into a number, and you need to perform the addition or subtraction to decrypt or encrypt, and you will be getting a ciphertext. So if you are those who are preferring method 1, then you need to focus on this table. So this table 26 into 26, so based on the so this will be the plain text and this will be the key. So you can match this and get the ciphertext. So the strength of Vigenere Cipher is polyalphabetic cipher, like use multiple substitution alphabets. Same plain text letter can encrypt to different ciphertext. Simple frequency, it's immune to simple frequency analysis. In English, E is almost the most common letter. In a Caesar cipher, E is always becomes H. So hacker just look at the most common letter in Vigenere because the key changes. E could be R on time and L the next. It hides the language pattern, right? So better than Caesar cipher, much stronger than the Caesar, and monoalphabetic substitution cipher we have used in Caesar, but in Vigenere cipher we used polyalphabetic and breaks the single letter frequency pattern, as I said before. Simple to implement, easy to understand and implement easily, requires only the keyword and Vigenere table. Useful for learning basic cryptography concepts, resilience to basic attacks. So it is not easily broken by single letter statistics, or more secure than early substitution techniques. So the weakness, if you see, vulnerable to Kasiski examination. Repeated patterns in ciphertext reveals the key length. Once the key length is known, the cipher becomes weak and vulnerable to Friedman test. Statistical methods can determine the key length, and then after a key length found, the frequency analysis can be applied and easily we can crack it. So repeating key weakness. So if keyword is short and get repeated, then the pattern appears in the ciphertext. So security reduces drastically. So not secure for modern use, so can't withstand a modern cryptography attacks, easily broken using the computers, not suitable for real world or secure communication. So in our YouTube channel we are started posting the cryptography, network security, and roadmap for cybersecurity, and also we have started posting the cybersecurity jobs in government and private sectors. So those who are reading in this domain or is looking for job in this domain, please like and comment and subscribe the channel. I will be posting more videos in cryptography, network security, and computer networks, and also cybersecurity career. So mostly I am focusing on cybersecurity career. There are many videos is coming, like there are almost 22.4 lakhs per annum in government. There are some government jobs. I'm going to post it soon. So if you are interested, just have a look in my YouTube channel. So whenever I post the video, please look into it and apply for the job. Okay, so thank you for time. Don't forget to like, comment and subscribe my channel. Thank you.